Hello student, welcome to my class. So far we discuss what is refraction and how refraction phenomena process when ray of light traveling from rarer to denser or denser to rarer medium. We already discussed refraction through glass slab. Now we will discuss the new concept, that is refraction through a prism. So what is the meaning of refraction through a prism? We already discussed. Suppose there is a slab, suppose here there is a glass slab like this, and it is three-dimensional figure. So this is a glass slab. When ray of light, this first phase, second phase, because a slab consists of 6 phases, so when a light is incident here, then it bend towards this direction, and finally we get this is the direction of the slab. That means it lateral displaces from its original path, and this distance is d. We already discussed this distance is known as lateral displacement or lateral shift. Clear? So this is the case of a glass slab when ray of light cross two parallel plate or cross two parallel refracting surface in this direction. Here deviation is 0. But what is the concept of prism? This slab also called a prism. How? If a ray which traveling, suppose this ray traveling this direction, if we choose here, then a ray which incident this refracting surface, again it just change its original path. That means if we reflect here, incident here, then it refracted this direction and finally come to this direction. Clear? And this angle is known as angle of angle of prism. So what is angle of prism? If you take here a two-dimensional figure like this figure, suppose this is a slab and here the ray is incident at some certain angle, then it refracted through this the medium, and again if you draw a normal here, it deviates from its original path like this, and this angle is known as angle of prism. Clear? So the prism is not a particular diagram, actually it is the concept, and it can be, this concept can be applied when there is two refracting surface. This is also refracting surface, this is refracting surface, this is refracting surface, and this is refracting surface. But in case of glass slab, it consists of 6 refracting surface. We need 2 refracting surface, and this refracting surface inclined at a particular angle, because these 2 refracting surface inclined at a particular angle, and here a ray pass through these 2 refracting surface and consist a angle is known as the concept of prism. So what is the concept of slab? The concept of slab means a ray which passing through 2 parallel refracting surface. This is 2 parallel refracting surface, and here we can write, suppose this is a ray traveling this direction and it again bend this direction. If you draw a normal, again travel this direction. That means it just displace from its original direction, and this refraction takes place 2 parallel plate. So this is the concept of slab, and this is the concept of a prism. So if we take suppose we have a triangular prism like this, this is also a prism. Here 3-dimensional figure, this is a prism. Clear? When a ray of light which incident this point and then refracted through this medium and finally come out the emergent ray, so this angle is known as angle of prism. Clear? Because these 2 surfaces are inclined with each other and there is a common angle A, and the ray of light which passes through these 2 refracting surface through a particular angle, so this is known as a prism. If we cut upper part of it, then suppose if we cut it, then we get a prism like this. This is the cutting part. Okay, this is also a prism. If we incident this angle, then refracted through this direction and finally emerge towards this direction, and this angle is known as angle of prism, you can say, or simply you can write, if two dimensional figure, this is total prism, suppose A, and if we cut here, then this is also known as a prism. How? If a ray which incident this point, then refracted to this direction and finally emerge out in this direction, and there is a common angle A, this is also known as prism. So from this diagram we conclude that prism is the concept of a refracting medium. That means when a ray of light passes through two inclined refracting surface and consists of a particular angle, that is known as angle of prism, and that is known as the concept of prism. And what is parallel concept, or what is slab concept? This is slab concept. What is slab concept? When a ray of light which passes through two refracting surface and these two refracting surfaces are parallel to each other. This is the concept of slab, and this is the concept of a prism. Again, suppose this is the two-dimensional figure of a prism, then if we incident a ray here, then it travel this direction and finally emerge out this direction, and this angle is known as angle of prism, because these two refracting surfaces are inclined with each other with a common angle, and this ray which passes through these two refracting surface, this concept is known as concept of a prism. Similarly, we can take, suppose there is another ray which is traveling this direction, and it this direction means refracted ray, and finally emerge out this direction, and there is a also common angle, suppose this angle B, and this is also the concept of prism, and here the angle is B, here the angle of prism B, here the angle of prism A, and if you take another ray like this and refracted this direction and finally emerge out this direction, suppose this angle C, and here the angle C is known as angle of prism. So this is the idea about what is prism. Now we have to derive a formula of prism, and suppose a prism whose refractive index mu, then we have to derive a formula, that is mu equal to sin A plus dm by 2 divided by sin A by 2. Clear? So that means this is the prism formula, and this is important long question for your council examination. So refraction through a glass prism, suppose there is a prism and this is two-dimensional figure. So diagram is important here, you have to remember all the diagram. Then suppose this is incident ray, which suppose there is a prism A, B, C, and if we consider two refracting surface AB and AC is two refracting surface, this is incident ray which strike at this point. Clear? Suppose this point, if we take point P, then first we have to draw a normal at this point, and this angle is known as angle of incident. And when a ray traveling from rarer to this is denser medium, suppose its refractive index mu, and this is also rarer medium. When light traveling from rarer to denser medium, it bends away, it bends towards the normal, because this is the line of action of incident ray. Clear? And it bends towards the normal like this. Clear? This direction, it bends towards the normal, and this angle is known as angle of refraction for first refracting surface AB. Okay. Now the ray, this ray is known as refracted ray, which travel in a straight line direction within the medium of refractive index mu, and again strike another interface which separating by two media, and that interface is known as AC. And this interface and this ray is incident ray for this interface AC. Now this incident ray which incident at this point, suppose this point is Q and here this point is P and this point is suppose Q. Clear? And now we have to draw a normal at this point. So this normal, this is normal N1 and here this is normal N2. Clear? And here this angle is 90 degree and here also this angle is 90 degree. Suppose this angle is known as angle of incident because this is incident ray for this refracting surface. So this angle is known as angle of incident. Suppose this is R2 and again this ray traveling from denser to rarer medium. That means this ray traveling this direction. This is actual path of this refracted ray or incident for this refracting surface. So this traveling this direction, but when they are traveling from denser to rarer medium, it bends away from the normal. That means it's bent towards this direction, and this ray is known as, that is emergent ray, and this ray, this is incident ray, and this is emergent ray, and this total angle is known as angle of emergent E. We already know. Clear? Okay. Now first case, this is the direction of incident ray which deviate from its original path. So this angle is known as angle of deviation, that is delta 1. Clear? And again look at this diagram. This is the incident ray for the second refracting surface, and in this case this is the actual path or line of action of incident ray, but is deviate from its original path, and this angle is known as, that is delta 2. Clear? If we join this line here, then this is the final ray or emergent ray after refraction through the glass prism like this. So here if we join this line, this is the total deviation and we can write, that is delta net. Clear? Total deviation for two refracting surface. So here suppose this angle is known as angle of prism, or we can take this 2 point. Suppose this point is P and suppose this point is Q and this point is R, suppose R, then this angle is known as angle of prism which is A. Clear? PQR. And suppose this point we can take, that is this point is X and here this point is Y, and suppose this point where two normal are intersect each other, suppose this point is known as, if we take another point here, then X, Y, this point suppose M, this point M, again there is another point A, B, and suppose this point is D. Clear? This point where emergent ray appears to meet with the line of action of incident ray, this point, because this is total deviation, because this is original direction or initial ray traveling this direction which deviate from its original path and emerge finally this direction, and this angle is known as total angle of deviation. Diagram is important here. Clear? So in this diagram the total deviation, because here deviation which is delta 1 in clockwise direction, and again here the deviation delta 2 also clockwise direction. So here total deviation we can write here, total deviation, suppose delta net, and delta net which is equal to delta 1 plus delta 2. Why? Because these two deviation are along the same direction, so we can add general, that is delta 1 plus delta 2. Now we have to find the value of delta 1. This is delta 1. Clear? So how can we find this delta 1? This angle is I and this total angle also I for fast refracting surface or at point X. So at point X we can write here, that is this angle I which is equal to delta 1 plus R1, that is delta 1 plus R1, and here delta 1 equal to I minus R1. Clear? This is first delta 1. Similarly at point Y, or you can write at interface PQ, and this is interface PQ, and similarly this is interface PR, and or interface PR at this point. Here total deviation delta 2, but this is total angle E, and this angle, because this is R2 means this angle also R2. So R2 plus delta 2 which is equal to E, that is R2 plus delta 2 which is equal to E, and delta 2 here, that is E minus R2. Clear? So we get delta 1 and delta 2, but we have to find total deviation delta net which is equal to delta 1 plus delta 2. So here that is delta net which is equal to delta 1 plus delta 2, and if we place the value delta 1 is here, that is I minus R1 plus delta 2 E minus R2, and we can write delta net equal to I plus E minus, that is R1 plus R2 bracket. This is important relation between total internal reflection, incident ray, emergent ray, and angle of refraction. This is angle of refraction R1, and this angle is R2. Clear? Okay. Now next start another concept here. So there is a quadrilateral PXMY. Clear? So in quadrilateral PXMY, and we already know all the angle. If we add sum of the 4 angle which is equal to 360 degree, and here this angle is, or we can write XPY. Here XPY angle plus this angle means this total angle. So PXM angle plus MYP angle plus MYP angle, then first XPY, then PXM, then XMY. So you can write here, it is XMY angle, then MYP angle which is equal to 360 degree. But this total angle, this angle is 90, and again this angle also 90, and this angle is here also 90 degree. That means here angle 90 and this angle 90. So you can write this angle P means this angle represented by A. So you can write here A plus PXM, this angle, total angle 90, because this is normal, and this normal always perpendicular to the interface. So this angle is here 90 degree plus XMY plus this angle XMY, that is XMY. Clear? And suppose if we take this angle, this is N1, if we take this angle, suppose N. Clear? So you can write here this angle which is equal to N plus MYP, and this angle also 90 degree which is equal to 360 degree. Now A plus N which is equal to 90, 180 minus 360 minus 180 which is equal to 180 degree. So A plus N which is equal to 180 degree. This is equation number 2. Now again look at the triangle XMY. In triangle, again in triangle XMY triangle, here the sum of 3 angle which is equal to, here this is not Z, this is N, sum of three angle which is equal to 180 degree. That means here r1 plus r2 plus n which is equal to 180 degree. This is equation number 3. Now comparing these two equations, comparing equation 2 and equation 3, then we get right hand side are equal, so left hand side must be equal. So a plus n equal to here r1 plus r2 plus n, and n cancel, so a equal to r1 plus r. This is also another important relation, and this is relation number 4. Clear? Now this replace the value of here, because this total angle r1 and r2 which is equal to, what is a? A is angle of prism. So this is angle of prism, so can replace here. So total deviation delta net equal to, that is I plus E, angle of incident, angle of emergent, minus r1 plus r2, that is we can write directly A. Clear? This is from equation 1. From equation 1 we get this relation. So here delta net equal to I plus E minus A, and we can write this is relation number 5, relation number 5. Clear? Now the important case we will discuss here for graph. The graph between total deviation or angle of deviation with incident angle. Clear? If you draw a graph, angle of incident versus angle of deviation delta net, then we get a graph like this. Here x axis and this axis, suppose y axis. Along x axis, if we take incident ray, and here I, this direction, and here we will take the deviation delta net this direction, total deviation delta net. So here we will find a relation, or we find a graph like this. You have to remember this graph, and this graph is important. This is the graph of this relation. Clear? And suppose this is angle of incident, and another one concept is here. If there is a triangle, then this is the incident ray traveling this direction, refracted ray, and finally emerge out this direction. This is angle of emergent, this is angle of incident. Clear? Similarly, suppose this angle is r1 and here this angle is r2. Again, if we take another one triangle like this, same triangle, this is area, angle of triangle, suppose here A, and if we take another one triangle, this same triangle also, suppose this angle of prism which is equal to, this is angle of prism, angle of prism A is here, and this angle of I. If we incident the ray at an angle of emergent, this is angle of incident, this is emergent ray. Similarly, if we take here, if this is emergent ray, if we pass incident at emergent angle, then this ray travel this direction, and this is r2 and this angle also r2, and similarly again travel this direction, and which is angle r1, and this angle also r1, and finally emerge out at an angle I. That means if we incident here at an angle 30 degree, suppose its refractive index √2 or √3, then we get, suppose we get here the angle of emergent which is equal to 60 degree. Again, if we incident here at an angle 60 degree, then we get the incident ray, or if we again incident here 60 degree, then we get the emergent ray which is equal to 30 degree. That means if we incident 30 degree, then emergent angle 60. If incident angle 60, then emergent angle 30 degree. Look at this relation. I plus E. This is I plus E. 60 plus 30 equal to 90. Again 60 plus 30 equal to 90. Because this is constant, A constant here. So angle of deviation is not changed. If we change the angle of incident, so there is two value for the angle of incident for which the deviation which is constant quantity. So if we choose there is a point, this point, suppose this angle is angle of incident, at that time there is another point also for which the deviation is constant, that is here delta net, which is constant quantity, and suppose this angle is known as angle of emergent, we can write E. Why? Because for two particular value and this deviation which depends here angle of incident and angle of emergent, this case. So and this is the final case, this is final case like this, and this is known as maximum deviation, delta maximum deviation. And when we get maximum deviation, because this is incident ray and this is here, if we incident this direction, angle of incident 0, angle of incident increase and finally 90 degree. So finally we get angle of incident, means this angle will be 90 or this angle will be 90. So finally we get this direction, means here the angle of incident should be 90 degree. This is final case. We cannot increase and further because this is the total angle will be 90. So at that time we get the delta maximum. Clear? So deviation will be at that time which is maximum when angle of incident, this angle or this angle will be 90 degree. Clear? So this graph is not at infinite, then this graph is last here at incident angle pi by 2 degree. Again there is another particular angle, suppose this angle or this is the deviation. When we increase the incident angle from 0 degree, sorry, at a particular angle, this angle particular angle, suppose we increase the angle which is at 30 degree, incident 30, 31, 32, 33, 34, at a particular angle where the deviation is minimum. Deviation is here minimum because deviation decrease and again deviation increase. So at a particular angle of incident I, here this angle is angle of incident I, at that time this is point, if we draw a tangent at that point, then here the angle of incident and angle of emergent lies at one point. That means when angle of incident is equal to angle of emergent, then we get a deviation through prism, and the deviation is known as, that is minimum deviation. So condition for minimum deviation, when angle of incident is equal to angle of emergent, suppose this angle 30 degree, then we also get here the angle of incident is, sorry, emergent is 30 degree. If here angle of incident 60 degree, then we get this angle also 60 degree. At that time the deviation through this glass prism is minimum deviation. This is the condition for minimum deviation. Actually this is the representation of a graph. If we understood from this diagram, then if we increase, suppose this is the angle of incident I, at that time this is the initial direction and here this is the line of action of incident ray, but this ray emerges out this direction. This angle is known as angle of deviation, delta net, this is final angle. Again if we increase this angle, suppose this angle is here 30 degree, suppose this angle 30 degree, at that time this is total deviation because this is the direction and this is total deviation. Suppose this deviation, suppose 50 degree, we get 50 degree emergent angle or total deviation here 50 degree. So this is not emergent angle, this is total deviation here 50 degree. Now if again we increase this angle of incident, suppose we increase 35 degree, then the deviation now decrease. Deviation first maximum this 50 degree and deviation decrease, that means again we get deviation like this direction, and here the angle now decrease. Suppose this angle is 48 degree. If we again increase this angle, suppose 40 degree, and again this angle also decrease, that means this angle suppose 45 degree, and we increase the incident angle, then the angle of deviation decrease and come to a final, and this deviation will be minimum. When deviation will be minimum, at a particular value of angle of incident, because we continuously increase the angle of incident. Continuously increase the angle of incident. At that time, this is first deviation, and deviation decrease and reach a particular value of minimum value. If we again increase the angle of incident, then this deviation again increase in this direction. That means here first deviation decrease, and for a particular value, and this is minimum value, then this deviation again increase. This graph look like here. Clear? And where the deviation is minimum, this is minimum deviation, and this minimum deviation at that time, the angle of incident which is equal to this angle of emergent, this angle. The angle of emergent at that time, angle of incident, and this refracted ray which is parallel to the base, this is base. This refracted ray which is parallel to the base at the time of minimum deviation. And there is also another condition. If these two rays are parallel to each other at that time, this R1 and R2 also equal. So, what is the condition for minimum deviation? For condition for minimum deviation, that means here delta net will be delta minimum. Clear? What is condition? At that time, angle of incident equal to angle of emergent, this is first condition. And what is second condition? The R1 equal to R2, this is important condition. And third condition, refracted ray is parallel to the base. This is base. Clear? So refracted ray parallel to the base. Again I repeat my sentence. When we increase the angle of incident continuously increase, then first angle of incident, the deviation is this direction. If we again increase the angle of incident, then deviation come decrease. This is original path. Then deviation decrease and reach a particular value, and that value is known as minimum deviation. At that time, this angle is known as, and this angle of incident and this angle of emergent will be equal. And suppose this angle is at that time 38 degree, because this angle increased from 30 degree. At 38 degree, this angle also 38 degree at that time, and here the deviation is from its original path, is this deviation will be minimum. And again if we increase this angle 41 degree, then again deviation, this is minimum deviation, again deviation again increase this direction. Clear? Up to this angle is 90 degree. When angle of incident is now 90 degree, at that time the deviation which will be maximum. So if we increase continuously angle of incident, then deviation decrease and reach a minimum value, and again increase this direction. Clear? And this minimum value is known as minimum deviation. At that time, angle of incident equal to angle of emergent, and this refracted ray which is parallel to base, and R1 equal to R2. This is three important case for minimum deviation. Clear? So this is minimum deviation, and this point is minimum deviation. And this graph, look at this diagram here. This graph, if we erase this point, this is for understanding purpose. So here this point and this point, this is not a symmetrical graph. You have to remember this point. This graph is not symmetry on both sides. Symmetry on both sides means this is a minimum deviation delta m is here. This is the first side. This distance, suppose x1, and this distance is suppose x2, this distance and this distance, this is not symmetrical. That means x1 is not x2, and from this graph we conclude that x2 greater than x1. Clear? This graph is not at infinite because it is last when angle of incidence is 90 degree. Clear? So this is not symmetrical shape. This is the condition for total internal reflection. Now come to this statement here, that is A equal to R1 plus R2 for minimum deviation, that is A can be write this equation from equation 3 or 4, from equation 4 IV, which A equal to R1 plus R2. Here R1 equal to R2, so you can write that is R1 plus R1 because R1 equal to R2, or you can write R1 plus R1, and which is equal to 2R1 equal to A and R1 equal to A by 2. Clear? We get the value of R1. Now come to this point. Again from equation number 5. From equation 5, here delta maximum or delta max or delta net tends to delta minimum for minimum deviation. At that time we can write delta minimum equal to I plus I, because I equal to E, so we can write I plus I minus A, and we can write here A, and I plus I which is equal to 2I minus A, and here delta minimum, and 2I equal to A plus delta M, means delta minimum. So angle of incidence equal to A plus delta minimum divided by 2. This is another important relation. So this is important R1 and this is R2 for minimum deviation. Look at this diagram, and for fast refracting surface, for refracting surface, for refracting surface PQ, for PQ refracting surface, if you use Snell's law here, then that is we can write here, we have a Snell's law, that is mu1 sin I equal to mu2 sin R. Look at this relation or fast refracting surface. Here angle of incidence I, but here refractive index mu1 which is equal to 1 for air medium. So you can write this is 1 into I, and sin I is your same I, so you can write here that is sin I which is equal to, or suppose this angle, suppose this refractive index mu1 for other medium, that is mu1, suppose this refractive index mu1 sin I which is equal to mu2, and this is second medium here mu, so you can write here this medium mu2 which is equal to sin R, and R is here refracting angle here R1, so you can write here R1. Now we need, or we have to find the value of this refractive index of this glass prism, and here mu. So here we take mu2, suppose this is mu2, so we can write mu2 which is equal to, or mu2 which equal here mu1 sin I divided by, that is sin R1, and mu if you divide here, that is mu2 by mu1 which is equal to here the angle, that is sin I divided by sin of here R1. Mu2 by mu1 we can write again refractive index of second medium with respect to first to second. So this is relation, or we can write this relation, if refractive index of first medium, this is air medium, is 1, and refractive index of second medium is prism or glass medium which is equal to mu. So mu by 1, you have to remember this relation, refractive index of second medium with respect to first, mu2 by mu1, and here mu1 is air medium, mu2 is mu. So you can write here which is equal to mu, or refractive index of mu means refractive index of prism, this is mu is here, so mu equal to, that is sin I divided by that is sin R1. Now if we use this value I is here, R1 is also here, so in this case we can write refractive index mu equal to, that is sin I, and I is here A plus that is D minimum by 2 divided by sine of angle of refraction R1 is here, that is A by 2. This is important long question for your council examination. Find the refractive index of a prism for minimum angle of deviation. At that time you have to solve this relation and you will get mu equal to sin A plus dm by 2 divided by sin A by 2. What is A? Angle of prism. What is delta minimum? Minimum angle of deviation divided by 2 is here. This is the required relation for refractive index of a glass prism. And by using this formula, you will solve different type of numerical based on this prism or based on minimum angle of deviation. Clear? If there is given the angle of incident and minimum deviation, then you can calculate the refractive index of that prism, or if given refractive index or angle of prism, then you can calculate minimum deviation. In this way you can solve different type of numerical based on this prism. Next we will start deviation produced by a thin prism whose angle of prism is very small or small angle prism. Suppose we have a small angle prism here, clear, and here this angle is very small, angle of a prism is very small A. Suppose there is a ray which is incident at this point, and if we draw a normal, this angle is known as angle of incident and it travel this direction. If we draw another, suppose this is R1 and this angle is R2, it emerges out this direction and this angle is known as angle of emergent, and this is first point. Suppose this point X and this point Y at point X. So if we use Snell's law at this point of refractive index mu, and here refractive index, that is mu equal to 1. This is rarer medium and this is denser and this is rarer medium, and this rarer medium, suppose here that is air medium and this medium is also air medium. So at point X, if we use Snell's law, that is mu1 sin I equal to here mu2 sin R. So here mu1 is air medium and refractive index 1 into sin I, which is equal to mu2, and refractive index mu into sin R, angle of refraction R1. So here that is sin I equal to mu into sin R. This is first relation. If we again look at this point Y, then if we use here Snell's law, we can write that is mu1 sin I equal to mu2 sin R. This is initial or general expression for refracting surface, and here this is incident ray for this refracting surface and this is R2. So you can write here mu1 means this relation indicate that the incident ray traveling which medium, and this is indicate that the refracted ray traveling which medium, and this is incident ray which traveling inside the prism of refractive index mu. So you can write here that is mu into sin I, angle of incident is here R2 equal to, that is mu2, this is air medium of refractive index here mu1 equal to, mu2 equal to 1, and sin R, which is emergent angle E. So from this relation we get that is mu sin R2 equal to sin E. This is second relation for thin prism. For thin prism, angle of incident I and angle of refraction, angle of incident, angle of incident and angle of refraction is very small. So you can write sin I nearly equal to I, and that is sin R nearly equal to R. That means sin R1 nearly equal to R1 and sin R2 nearly equal to R2 and sin E nearly equal to E. This is the condition we can write here. So first relation sin I, this relation we can write here, that is sin I which is equal to I equal to mu into sin r1 which is equal to r1, so mu r1, this is nearly equal. Again this relation mu r2 which nearly equal, that is E. Clear? So we have a relation, that is delta net equal to plus I plus E minus A. And if we use this relation, I equal to is here, I equal to mu r1 plus E is here mu r2, it is mu r2 minus A. Clear? And here mu constant quantity, we can take it out of the bracket, so r1 plus r2 minus A. As we have a relation A equal to r1 plus r2, if we use this relation here, then delta net equal to, we can write mu A minus A, which is equal to mu minus 1 into A, that is delta net. Clear? So for thin prism, the angle of deviation, total angle of deviation, which is equal to refractive index of prism minus 1 into A. If this medium is air medium, if this medium other than air medium, suppose this medium is surrounding medium and this medium also surrounding medium, and here refractive index, that is mu s, and this refractive index, that is mu p for prism, and this refractive index, that is mu s for surrounding medium. At that time you can write a relation here, delta net or refractive deviation produced by a thin prism, and this prism which placed inside a surrounding medium whose refractive index, that is mu s. At that time you can write the relation here, delta net equal to mu means, we can write, that is mu p means prism divided by, that is mu s, because here surrounding medium is air medium, so divided by 1. If other than air medium, at that time we have to write mu p by mu s minus 1 into A. This is the formula for deviation in case of thin prism or small angle of prism. Now we will start dispersion. So what is the meaning of dispersion? Dispersion means, suppose there is a light, that means this light which is white light which incident on a surface, and here suppose this medium is air medium and this light is white light. What is white light? It is the mixture of all the color of light and is traveling from rarer medium to another medium, denser medium of refractive index mu is here. And first we have to draw a normal at that point of incident, and this angle is known as angle of incident I. Clear? Now look at the diagram, and we already know a relation, that is electromagnetic wave, and this region is known as 3600 angstrom to here, that is 7600 angstrom, and this region is already known, that is visible region, which we are able to see within a range of wavelength which is equal to up to 3600 angstrom to 7600 angstrom, and this region is visible region, and here we get Vigor 7 color of light, GIOR 2, 3. Clear? That means when if we travel this direction, then wavelength decrease, lambda decrease, but velocity equal to lambda into frequency. Velocity of speed of light which is equal to, or we can write C equal to hf. If, because C is constant for vacuum, 3 into 10 to the power 8 meter per second, at that time if lambda decrease, then frequency increase, because C is constant quantity. So if you come to this direction, here lambda decrease, at that time frequency increase. This relation we have to apply here. So if we use this relation here, then this angle is angle of incident I. It consists of 7 color of light, that means Vigor, violet, indigo, blue, green, yellow, orange and red. This is known as 7 color Vigor, and which lies in electromagnetic spectrum within the region of wavelength 7600 angstrom to 3600 angstrom. If we move this direction from red to this violet, then wavelength decrease. That means the maximum wavelength consists red light and minimum wavelength consists violet. But which frequency is maximum? So the light which consists violet light and its frequency maximum, and red light its frequency minimum. So here we have to apply this relation. Actually, what is dispersion? Dispersion phenomena. Dispersion phenomena means when a white light traveling from one medium to another medium, it split all the colors, it scatter all the color, all the wavelength of light which consists this seven color of light, because this white light consists seven color of light. When it traveling from air to denser medium of refractive index, then here it's suppose here that is wavelength lambda 1, lambda 2, lambda 3, lambda 4, and finally we get lambda 7. So when light traveling from one medium to another medium, air medium to denser medium, in denser medium 7 wavelength of light are splitted. So that means this light traveling in this way, because this is the actual ray traveling this direction. If we increase just the angle of incident like this is angle of incident and it constitutes white light. So this is the line of action of white light, and this angle is known as angle of incident. I is here. Now this white light split in 7 color while traveling from air to denser medium of refractive index here. So then this light in this direction, this is fast light traveling here, because it consists 7 color. So 7 colors scatter 2 and 3, 4, 5, 6, 7 like this, in this way. Clear? If there is another medium, 3, 4, that is 5, 6 and 7 color. 1, 2, 3, 4, 5, 6, 7, because it is a mixture of 7 color. This is known as dispersion. Dispersion means it scatter all the wavelength of light while traveling from air medium to another medium. Now question arises here. This is the actual line of action. Then which ray or which wavelength of light out of this 7 wavelength of light whose deviation is minimum, because this is deviation for first, second, third, fourth and fifth, and whose refractive index, because this is normal line, and whose refractive index whose angle of refraction is minimum and whose angle of refraction is maximum. Clear? To study this concept, we have to use a relation that is known as Cauchy's condition or Cauchy's formula. One of the most important scientists which give the idea about dispersion or wavelength and relation between refractive index of the medium and wavelength. Suppose here refractive index, this medium is mu, and this formula, that is mu equal to A plus B by lambda square plus C by lambda fourth plus so on. This is relation is known as Cauchy's formula. And what is ABC? ABC are constant quantity which depends on this medium. And what is mu? Means refractive index of the medium. What is lambda? And mu is here, that is refractive index of the medium, and lambda is here wavelength of light. Clear? Because light consists of 7 color Vibgor. So whose this relation, if we look at this relation here, that means here refractive index is inversely proportional to wavelength of light. So we can write mu is inversely proportional to 1 by lambda. For this relation, Cauchy's relation. Clear? So if lambda increase, then refractive index is decrease. Clear? Or suppose this is the medium, or in this case we can write here, if we use Snell's law at this point, that is mu1 sin I, which is equal to mu2 sin R at this point. So this point angle of incident I, but this suppose this is air medium of refractive index mu1 equal to 1. So can write here 1 into that is sin I, which is equal to mu2 sin R. So here we can write mu2 means refractive index here mu into here that is sin R. Clear? Or here this angle is known as angle of deviation, this angle deviation and this angle deviation. Clear? So here we have to find a relation mu and R. So can write here that is R equal to or sin R. Sin R equal to that is sin I divided by mu, because I angle of incident which is a constant quantity. So can write here that is sin R which is equal to 1. Suppose this constant quantity suppose 1, or you can write here, or this relation you can remember this relation here, this is constant quantity. If here lambda increase, then refractive index decrease. So refractive index decrease means this lambda increase. You have to remember this relation. Lambda increase, refractive index of the medium decrease. If refractive index decrease, then R increase. So what is this concept? Here R, O, Vigor, 7 color of light. So the maximum wavelength which is R, that means for red color of light it is R, its wavelength increase, because maximum wavelength 7600 angstrom at that time lambda increase means refractive index of the red light while traveling from rarer to denser medium it decrease, and here mu decrease means this decrease, and R, what is R? R is here that is angle of refraction. Here angle of refraction increase, so here R increase. This is for red light. And again come to violet light. For violet V, and here lambda decrease because this is final and it is nearly about 6300 angstrom. Lambda decrease, then mu refractive index while traveling from one medium to another medium, mu increase, and here that is R, and here mu increase means R decrease, so R decrease. So this light, because this is small angle R and this is large angle R, because we always measure the refracted angle from normal side. So here R decrease means this is small angle, here R increase means this is large angle. For red light this is large, so this is known as red color of light. And finally this color is small angle R, so this is known as violet. Clear? So this is violet and this is red. Then all the light which is between red and violet color, then other color you can write this is ray OR, Vigor, like this. Clear? So question arises here, whose angle of refraction is very small? Whose angle of refraction is small? Violet light. Whose angle of refraction is large? Red light. Whose deviation is small? Because this is deviation for red light. This is original path. This is known as delta 1. This is known as delta 2. So here delta 2 greater than delta 1, and delta 1 for red, and here delta 2 is for that is violet color. So here you have to remember, if we discuss about R, then R red refracted angle, violet refracted angle, then whose angle is greater than red light angle of refraction is greater than violet light. Again if we compare deviation angle, this is delta 1, or we can write here delta R and delta V, whose deviation is maximum. This is R and this is violet, so violet is here maximum. So this is important case, important relation question may arise in your council examination for short question. Clear? Okay, if we take another one example, this is one slab. Suppose if we take a prism here, and this prism is thin prism and whose angle is A, and when a light incident here, suppose a red light is incident here, then this is the angle of incident, this angle is I, and this light is white light which consists of 7 color, and here this ray traveling this direction. First this is normal and it deviate, this is violet because this angle is very small, so this is violet light, this is violet, and this is last one is red. So here this is the direction of line of action, and the last one is red is here. Again when traveling this direction, and this is violet and this is red and violet, then another rays or another wavelength of light which in between red and violet. Clear? One, two, three, four, five, six, seven. V, I, P, G, Y, O, R. If we place a screen here, then we get all the wavelength of light which consists of white light. V go like this. Clear? And this is the initial direction of this direction, and if we take here, then all the rays are meet at a point, then this angle is known as angle of deviation of R, and this total angle is known as angle of violet is V is here. Clear? And this angle means appears to meet at this point means this angle, so this angle is known as theta, and theta is known as angle of dispersion. So what is the difference between angle of deviation and angle of dispersion? Angle of dispersion means it is the angle between red color of wavelength of light to violet color of wavelength of light, theta. So theta can be write here, that is delta V minus delta R. Clear? And theta is known as angle of deviation. So you have to remember all the concept one by one, which is important thing for your council examination or any entrance examination also. So theta is here delta V minus delta R. Clear? And we have a already relation for thin prism, we can write here. This is thin prism, and we have relation for thin prism. We have a relation for thin prism, that is delta net, which is equal to refractive index of the medium or prism mu minus 1 into A. This is a general relation we already discussed in before 2-3 minutes, that is mu net equal to mu minus 1 into A. For delta V means red color of light, so you can write that is delta R means deviation for red color, which is equal to mu minus 1. Mu minus 1 means mu R minus 1 into A. This is for red, and for violet that is mu V minus 1 into A, because angle of prism is constant. So this angle is theta is known as dispersive angle. So you can write here angle of dispersion theta, which is equal to, that is delta V minus delta R is here. So delta V, which is equal to mu V, that is mu V minus 1 into A minus V R here, that is mu R minus 1 into A. Now if we open the bracket here, then we can write A common quantity, then the remaining part mu V minus 1 minus mu R, this is minus minus plus 1, so plus 1 minus 1 cancel, so theta dispersive angle, which is equal to A into, that is mu V minus mu R. This is another important formula for dispersive angle and refractive index of violet and refractive index of red. Then one more important thing here, it consists 7 color of light, this is red and this is violet. the violet color of light which is nearer to normal, and the red color of light which is just just large distance from the normal, and angle of deviation of red is minimum and angle of deviation is maximum for violet. Clear? And the angle between red and violet light is known as angle of dispersion, which can be write delta V minus delta R. Clear? Okay. Then here another ray of light, that is yellow color. So again we will come to the concept, that is yellow color, this color of light which is yellow color. And this yellow color light which is sensitive to our eye, maximum sensible light is known as yellow color light. So this yellow color light is known as, here this is yellow color and here this can be read, that is delta Y. Delta Y means deviation for yellow color of light which is equal to, that is mu y minus 1 into A. Clear? This is another important formula for yellow color of light, that is mu y equal to, delta y equal to mu y minus 1, deviation, and which lies between violet and red. And this yellow color light which is maximum sensible light between red and violet light. So angle of dispersion theta equal to mu v minus mu r into A. This is important formula, and this angle of dispersion is unitless and measure in radian, degree or radian. Clear? Dimensionless physical quantity, dimensionless, and its unit, that is degree or radian. Clear? Now another term, that is dispersive power. Dispersive power. So what is dispersive power? It is the ability of a medium and that disperse all the wavelength of light. That means suppose if we take this is a medium and this is the actual ray traveling this direction. Suppose this is glass medium, and here the angle of deviation for R is 30 degrees. Suppose angle of red light is 30 degree. If you take another medium, suppose water medium, then angle may be 25 degree. So it depends on the medium. So this is another dispersive power. Clear? So dispersive power can be write here, it is represented by omega, and dispersive power which is equal to, that is theta by here this relation, that is angle of deviation, that is this is known as a minimum or mean deviation. This is known as mean deviation. Theta is here angle of dispersion divided by mean deviation. Clear? So mean deviation is taken for the yellow color of light. This color is yellow color of light, and here this is delta y equal to mu y minus 1 into A. Why this yellow color of light is known as mean color of light? Because this is the third position, this is red, this is orange, and this is yellow, and this is violet, indigo, blue, green. Then question may arise, sir, this is the in between red and violet, and green will be your mean value. But this is not mean value. Yellow color is taken to be mean value or average value. Why? Because this yellow color is sensitive or more sensitive as compared to other color. If we ignore red and violet, this is yellow color light which is sensible to our eye. So yellow color light is taken to be mean deviation. You have to remember this relation here. So angle of dispersion which is equal to theta divided by angle of deviation, that is y, and here theta is equal to mu v minus mu r into A divided by here yellow color of light here, that is mu y minus 1 into A cancel. Then angle of dispersion or dispersive power which is equal to, that is mu v minus mu r divided by mu y minus 1, and here this is unitless Dispersive, what is the unit of dispersive power? This is not what. This is a refractive index and this is also refractive index, and it is a unitless and dimensionless physical quantity. It is a dimensionless and unitless physical quantity. Clear? Okay. If dispersive power, so delta y, that means yellow color light is taken to be mean deviation, which is more sensitive to our eye. So if delta y is not given, what is delta I? Delta y means deviation for yellow color light. If deviation of yellow color light is not given to you, then you have to take the mean, delta mean or minimum deviation, which is equal to delta v plus delta r divided by 2. This is for minimum deviation if delta y is not given. If delta y is not given, then you have to take this relation. If delta y given, then you can take this relation. Clear? These are all about the refraction through prism and what is the formula regarding prism. This is important long question. What is dispersion and what is dispersive power? Clear? And what is angle of dispersion? So you have to remember all steps which will help your council examination and any board examination. Thank you.